Hello students, welcome back. Previously we went through some limit computation problems. Trivial limits? Oh come on, they're too simple. Just plug in, if it works, it works. If it doesn't, it doesn't. If you plug in and you ended up with 0 over 0, that means typically we need something. Typically we factor. Factor the numerator and factor the denominator and cross out common factors and you end up with a trivial limit. Now you can plug in the numbers. You have a lot of fractions, so let's increase the font so that you can read better. Okay, that's better. Another example with factorization. Sorry about the typo. So factor and then eliminate the common factors, and then what's left is a trivial limit. Now, if you do not have a rational expression, then no polynomial, no factorization. What do? Think about the conjugate. Multiply the conjugate of the square root expression to both numerator and denominator and simplify. Forward out carefully and then simplify the square root expression and then do your computation. You're going to get what you want in the end. A bit hard method, and there's going to be a bit more, there will be a little bit easier method, but that's coming up in several weeks. So for now, this will have to do. And then we started discussing infinity over infinity type limits. This is an easiest type. Basically, take the highest degree term, throw away the rest, and then simplify. But then again, here's a challenge. How do I throw away? What's the greatest term? Fourth power. So that stays and everything else gone? No. That's a big no. Why? Because it's not a fourth power. This one here is actually second power. Same as this. Because that power is inside the square root. All these, they're all unimportant terms. All these are unimportant terms. X squared, okay, that's important. And then 3x, of course, is not important. And here I have x squared, but no, not really. What's the order? It has actually first degree, just degree 1, because the second power is inside the square root. So there's nothing here that's going to contribute. Degree 1, degree 0.5, degree 0, no, just degree 2, second power, and square root of the fourth power, which is the same as second power. If you do that, then you're going to get this computation. Square root of 2, and then x squared, and then x squared, and then x squared. All good? What's the answer? Cross out, cross out, cross out, and square root of 2. I'm afraid I see this answer a lot. Basically, students are doing this. So cross out x squared, cross out x squared, I get square root of 2. Wrong. What did I do wrong? You cannot cross this one out directly. Let's take one more step. Let's factor x squared out. And what's left is square root of 2 minus 1. Now I can factor. Now I can cross out. Cross out x squared. The answer is square root of 2 minus 1. That's the limit. Yeah, here I can cross out x squared. If you do, this x squared does not completely go out. Does not go out to 0. goes out to 1, just like down here, goes out to 1, not to 0. Or you can factor out and then cross out. So the first step is to take the highest degree terms. Highest degree is second degree, not fourth degree, not third degree, second degree. And here, highlight in blue, here highlight in blue, and here highlight in blue. Not this one here, not this second power, and not this one here, not this third power. No, they do not contribute. That's not the highest degree term, and this is not really highest degree term either. Let's see, do I have a graphical solution here somewhere? Well, all right, I'll just plot it. Copy and paste this thing. By the way, I'm using Mathematica, but if you don't like it, or if you're unable to use it, then you can use any other kind of grapher, like Desmos graphing calculator or things like that. And when x is small, the behavior are not asymptotic at all. You cannot see anything. They look very different. But if I go from -50 to +50, okay, all right, by now I can clearly see the asymptotic behavior. So there are two different functions, yes, but the limit at infinity are the same, to the right and also to the left. So the limit is square root of 2 minus 1. Okay, let's go to the next problem. All right, this looks pretty similar. So here's the highest degree term, highlighted in green, and this one is not very important, so throw it away. And then this is second power, or no, this is first power. Remember, this is inside the square root, so this is degree 1. It's the same as this. And then +3 is not very important, so throw it away. And then this is important, and -2 is not important, so throw it away. Let's see, let me increase the font a little bit further. See that? Okay, all right. So if you simplify, what you get? Square root of 2, and then x out, and then divided by x. And then don't forget, do not just blindly cross out. X square root of 2 minus 1 over x. After crossing out, finally I get square root of 2 minus 1. Looks good? Let's verify graphically. All right. And square root of 2 minus 1. Oh. Plot -5 to +5, and of course they don't look anywhere close to each other. And then let's go from -50 to +50. Do you expect an asymptotic behavior? What do you think? Do you see an asymptotic behavior? Yes, you do, and looks good, but, big but. This limit is limit x toward negative infinity. Toward positive infinity, it looks good. Toward negative infinity, it does not look good. Clearly, this is not an answer. Square root of 2 minus 1 is not an answer. Look at this left-hand side. X is going to negative infinity. Not good. To the right, it looks good. To the left, it's wrong. What did I do wrong here? How do I correct it? Stop the playback and think about it. Well, if the problem had been x going to positive infinity, just positive infinity, and all those crossings, all those simplifications, and then got square root of 2 minus 1, it would have been right, and you can see that graphical behavior here. To the left, it doesn't work. Exactly the same algebraic computation did not work for x going to negative infinity. What's wrong here? The answer, right here, which I just highlighted in red. That's wrong. Why is that wrong? Square root of 2x squared, this square root is positive because positive square root. This expression here highlighted in red is negative because square root of 2 times negative infinity. So this whole thing is negative. This thing is positive. And original problem is positive. I got something negative. How do I make it right? By putting extra negative sign, I can make it right. Now this entire thing is positive. So instead of square root of 2, I get negative square root of 2. The answer includes negative square root of 2. And that's visible from the picture. Let's see. Do you want negative square root of 2 here or right? Negative square root of 2 minus 1 and then another color. Okay, look at this brown line. Does that look like a good asymptotic behavior to the left? Yes, indeed, finally. So this one here, which I just highlighted in brown, corresponds to this brown line. That is finally correct. So whenever you see x going to negative infinity, be careful. And the best way to see is to plot. If you plot and if you do not have nice asymptotic behavior to the left, something is wrong, and go back to your original square root. Original square root has to be positive. Square root times this x is negative, you need extra negative there. If this is extra third power or fifth power or 17th power, we all need this extra negative because odd power will keep negative negative. If that's an even power, then no problem. That's what happened in the previous problem. We have even power, so no problem there. And the graph had no problem either. Even power, odd power, that's a bit hard. So the best way, in my opinion, is to graph. Graph and check. And then if it doesn't work out, something is wrong and that's got to be extra negative. Of course, if you miss that altogether, you're not going to miss too much because this is an A-level problem. So end up with 9 out of 10 or 8 out of 10. That's not going to be too bad. Still, if you keep missing the extra point after scoring touchdown, by itself it's not devastating, but in the end, you may end up losing the game. So be careful about those kind of things.